Right. Hello, welcome to the second lecture. So this week is the first week of labs. So this week, please come to the labs. I will explain the first lab sheet, which is basically the installation of OpenNebula on your hosts. Okay. And before I do that, I will go through a bit of the basic design concepts for OpenNebula that you need to know. So basically the theory of what it all consists of and how it actually works before you actually go and install the thing. So the idea is that we are building a cloud of our own. Okay, so you need to have a cloud software in place. So that's what OpenNebula is, and we need to have a certain infrastructure in order to create all of this. Now, the difference between what we will be doing in the lab and what usually happens out in the industry is that all of the components of our installation, so all of the components of our cloud, will be located on one computer. Okay, so your computer will do everything, whereas in an actual production environment, you have different components of this spread across multiple different computers and different types of computers, and I will explain the architecture soon as well. So if we look at this diagram, what do we need? So first of all, we need the front end. So we need the software to be running somewhere and to be able to manage everything. So OpenNebula runs the front end, which is called 1D. So the main daemon, the main program that manages everything. And we need to have one computer that is the front end for this. Normally in a cloud environment, that would be one server that runs the OpenNebula software, and it can either be a server that is separate to the rest of the cloud, or in fact it can actually be one of the computers in the cloud itself, one of the virtual servers, one of the virtual machines in one of our virtualization servers. Now the components that our cloud consists of is the front end, the data stores, the service network, the hosts, and the virtual networks. The easiest one to understand is probably the hosts. So you need to have a bunch of servers, physical servers, that support, can you please switch your phones off, that support virtualization so that we can start our virtual machines in there. So those servers will basically provide us with the CPU cores and the memory that our virtual machines inside our cloud will actually end up using. We can have as many virtualization hosts as we can afford, basically. All right. And the more, the merrier, obviously, because the stronger the host and the more number of hosts you have, the stronger your cloud, the more resources available in your cloud will be. Other than that, you need to have the data stores. So you need to have a place that gives you storage space. So normally this will be a storage server or a network of storage servers. Okay, and that will basically allow you to use storage space for your virtual machine. So this will be where you build all of your images and where all of your data will basically be stored. Now, all of these, the three basic components, so the data stores, the front end, and the host, the visualization host, need to be connected together somehow. That somehow is the service network. So there need to be a fixed connectivity that is outside of the cloud infrastructure itself, and it needs to be direct connections essentially between your front end, your data store, and your hosts, so that they all can communicate with each other, and then the cloud actually just works. The component that's slightly irrelevant to all of them is the virtual machine networks. So your virtualization hosts will start up a variety of virtual machines. Depending on the size of the cloud, there can be tens or hundreds or thousands of virtual machines that are running. Okay, all of them need to be able to communicate with the virtualization host, and in some cases they might need to be able to communicate with each other as well, so that they can basically provide the connection that you need in order to do whatever it is that your business is doing. All right. And of course, they all need to be able to communicate with the front end, because the front end needs to be able to monitor those running virtual machines all the time. And of course, they need to be able to contact the data store, the file server, because as files, they will essentially live there. All right, so anything that is stored in the cloud will be stored in data stores. Now, our implementation in the lab will have the difference that all of these components will be on the same host. So essentially, your computer, your Prometheus virtual machine that you will have, will be the OpenNebula front end. It will provide the hard drive space for the data stores, and it will be the virtualization host that has the ability to start up the virtual machines. As such, and because we're doing this, we don't actually need a service network. For us, the service network is the fact that the host itself has a loopback network card, the local host, 127.0.0.1, and that can basically get everything to communicate with each other. So it's a simplified setup because of this, because you need to learn how to use it, and because the service network and the NFS shares and everything else that's involved with that makes things more complicated. Okay, and for somebody that's building a cloud with OpenNebula for the first time, it's not the best. All right, so it will simplify things a little bit more. So, everything that I said is explained in here. So you will need to read this before you come to the lab. All right. Other aspects of this, dimensioning. So when you're building a cloud in general, you need to decide what the cloud will be and how it will actually work. What you basically use it for. Okay. Please pull. So, you need to see how many CPU cores you can have in your cloud, how much memory, how much storage space, and how many and what types of network cards. So when we're talking about dimensions of a cloud, we're talking about the different resources that the cloud has available and can offer its users. You might not strictly be speaking about virtual machines per se. Okay, so you might not say that, I have 10 users, I'm going to need 10 virtual machines. It makes more of a sense to say I have 10 users, they will need so many CPU cores, because, 3 of your users might be researchers, so they might need to have 4 cores per CPU, 4 cores per virtual machine, for example. So in that case, you would need more than actually just 10. Depends on the amount of memory that you can have, the hard drive space that you can have, and the network cards that you can offer. And all of this is fluid in a sense, because you can change all of these characteristics dynamically, the dimensions of any of the virtual machines that you're running, even while you're running it. Okay, so if you're in the cloud itself, if you have a virtual machine that has 1 core, and somebody tells you, I need more power, I need to run a simulation, you give them 10 more cores, and they just run what they need to run. They stop running it, you take your cores back. Okay, so don't see it as, how many virtual machines I can run with this. See it as how many do I need of each resource, how much do I need of each resource in the cloud for each of my users. The OpenNebula front end has a very light requirements. It's not a very heavy thing to run. As a software itself, it's only about 150 megabytes anyway, so you don't need to worry about it. And in fact, our OpenNebula in our cloud runs inside the cloud. So it's brilliant. It's a chicken and egg situation. It's very funny, but yes, you can do that. So when we're talking about dimensions, we're talking about the CPU, so how many cores. In OpenNebula, you can overcommit. So let's say, for example, you have 10 users, okay, and you have 10 cores available in your system. You can create your 10 virtual machines, but you can possibly give all of your virtual machines 2 cores. Because not all of your users will be working at full capacity all the time. Okay, and the same can pretty much happen with the amount of memory and the amount of allocated quoted storage that you have on a system itself as well. You can also undercommit. So you can have 10 cores and you can give half a core or a third or a quarter of a core to a virtual machine when you run it. Okay, because there's a virtual CPU feature in the virtual machine settings when you create them, and you can basically do whatever you like with it. So that's very useful. So it all comes down to the management of the cloud that you want to do. Now, storage, there are 3 different types of data stores that OpenNebula supports. The first data store is the image data store. The image data store is basically where you keep your hard drives. So you have virtual machines, and they consist of maybe a hard drive and let's say a DVD-ROM image. All right. That can be, for example, the installation medium for your operating system. So when we build our first virtual machine, our template for our first virtual machine will consist of 2 images. One image will be a blank hard drive, an empty data block, and the other image will be an ISO image of the operating system that we wish to install. So all of these are stored at the image data store at all times. There is also available the system data store. So the image data store exists there just to store information in case you want to use it, just to store the images in case you want to use them. The system data store is more important because it's where things are kept when they are running. So in fact, when you do start up a virtual machine, the images that make up this virtual machine get copied from the image data store to the system data store. That way, even if something does happen to the images, to the image data store itself, it is not connected to your current running virtual machines, and they can be fine. Even more so, the other way around is more important, because if you have a running virtual machine that depends on the images that are running on the system data store and it crashes, you can restore it from the images that are kept in the image data store straight away very quickly. All right, so that's why it's done this way for resiliency and redundancy. So you don't have to, if something goes, then you have another backup of it somewhere else. The third type of data store is the user data store, and it just keeps files. So just random files that you might need to have available. Okay. The network itself, so all of the virtual machines that you create in your cloud should have at least one network card, really, so that they can communicate with the host itself. And this happens in our case only because everything is on the same computer. If there were other virtual machines, they would need to have at least 2 network cards, because they would need to have one network card that connects them to the service network, and then one network card that connects them to the virtual network that helps them communicate to the host and everything else. All right, so our VMs will basically have one network card to begin with. The front end has 2 components that we really care about, and one that we care about because it makes our life easier. So the 2 components that we need are the main daemon of the program, the main program, the 1D, and the scheduler. The scheduler helps you basically monitor the system and perform scheduled tasks, maintenance, and everything else that you need to do. We also have the web interface server, which is the Sandstone server, and this is what starts the website that allows you to monitor and manage everything. Essentially, you don't absolutely need the Sandstone server component. Okay, if you're running a server that does not have a graphical user interface, that it only exists in terminal mode because you want your server to be light and efficient and fast, then you don't need to have the Sandstone server interface available to use. All right. There are other additional options as well that I won't go through here. Monitoring is fine, virtualization host. So we will be using KVM for our virtualization. Okay. KVM is built into Red Hat Linux by default anyway, because that's where it started from. So you will have it in your virtual machine anyway, and you don't need to worry about it. It's basically a hypervisor that will be there and will be used once you need to use it, essentially. Storage, all of the files and everything for us will be held in our own computer. So as I said, everything is on one, so you don't need to worry about this too much. In more detail, you will have, like in a normal cloud environment, you would have a storage server somewhere or a cluster of storage servers in a data center somewhere, and that somewhere can even be in a different location completely with regards to the front end itself. Okay, it doesn't really matter where it is in the world. And that is connected to the service network and connects to the host and the virtualization, the front end, OpenNebula, and they basically just communicate and work with each other through network file services, whichever service you want to use basically for that. System data stores, image data stores, and everything else. There are different types of file systems that we use for this. It will all depend on what you want to do for your virtual machine. The simplest file system that we'll use for our VMs is called QCOW. And if you want to look into it more, you can basically just Google it and see exactly what it is and what it does. And as for the networking, as I said, you can have two different types of networking in a cloud: your service network and your instance network. The service network is not for the virtual machines to see and is not for the end users to know at all. The service network exists only for the administrators of the cloud to be able to communicate, to basically connect all the different components of the cloud between each other so that they all work correctly. All right. And the instance network is basically what the end user could possibly configure and use in order to get internet access on their virtual machines. There are different types of networking that we can use for our instance network. We will be dealing with Open vSwitch. Okay, it is the most flexible and the most customizable of them all, and that's why we're going to dedicate a considerable amount of time on this. The lab sheet itself is very easy, like literally copy and paste the commands and it will work. But understanding everything is another thing. Authentication, of course, there's building authentication into this. We will be using SSH, and we will be using passwordless SSH in order to make things easier. So one of the first things that you will do, and actually we'll see it on the lab sheet today as well, is to set up passwordless SSH between the virtual machines and the host. So between the virtual machines that we can start, our virtualization host, and the program that runs our cloud, the 1D daemon itself. Anything else? There are some advanced components, so they're here for you to have a read through and see what they are. We're not going to be using them in the lab. So we'll move on to the installation itself. First of all, in the lab, when you come, you need to log into your computers. Okay, you will have a username that will be VM6789 or whatever it is. All right, you log in, you have a password which is localhost 1. As soon as you log in, you need to change this password, and the instructions on how to do this are here. So once you change your password, you need to find and start up a virtual machine that is called Prometheus. So TB2 Prometheus virtual machine. You'll need to find that. It is a zip file, so you'll need to get it from the global folder, and you need to extract it essentially. It's a compressed file. Extract it into your home directory, and then open it up with VMware Player that we use on our computers. Now, once you open it with VMware Player, there are not many things that you need to do. The first important thing is, how do you log in to this Prometheus virtual machine? You need to always log in as user root. This is contrary to what we usually should be doing on any Linux machine. Okay, you should always log in as a normal user, and you should use the SU command in order to elevate your privileges and be able to basically perform administrative tasks. However, because we're in a test environment, we're in the lab, we're isolated from the rest of the world, and because I want to make your life a little bit easier, and because all of the tasks that you will perform will require administrative privileges, I want you to always log in as user root. Okay. In fact, the normal user's password on the virtual machine that I've created, you don't know it, and they won't tell you what it is, to save us the trouble. Okay. So you log in as root. Once you're logged in, the most important change that you need to make is the networking. So that virtual machine by default has an IP address of 148.197.28.253. All right. If you all use this machine as it is and don't change the address on it, then nobody will eventually have internet access because our routing on our lab will freak out. Okay, you need to change the IP address of your Prometheus virtual machine to whatever the IP address of your host is plus 100. So on the bottom left side of your monitors, there's a sticker that says VLAN something, 65, 70, 95, whatever it is. So that is the IP address of your physical host, of the computer that you're working on. Your virtual machine, your Prometheus virtual machine, needs to be whatever is on that sticker plus 100. So if you're working on computer VLAN 65, then Prometheus needs to have an address of 165. Okay. So you apply that, you change all the, you restart the network card and everything else, and then Google Chrome is installed already. You can start it up, go to Moodle, get the first lab sheet, which is the installation lab sheet essentially, and you can move on from there. You also should log in to your university Gmail account, go to your Google Drive, create a Google Doc, and name it Cloud Logbook and then your student number. Because then everything that you do in the system, you need to take screenshots of. All right, and you need to keep it as a logbook, and that's the easiest way to do it. Very, very warm request. Always do everything inside the virtual machine. Don't log into the computer, open a browser, open VMware Player, have Prometheus on one side, and then the lab sheet and the logbook on another side. As soon as you log into the computers in the lab, start up the virtual machine, full screen it, and then open a browser inside that virtual machine, go on to Moodle, get the PDF, because then you can copy and paste all of the commands straight into the terminal, and then the screenshots that you take, you can copy and paste them straight into the Google Doc from there, and vice versa. Okay, so it will make your life much, much easier, and you won't have any problems because it's a PDF that's been converted from Word, and if you try to copy and paste commands passed from outside the virtual machine to inside the virtual machine, some of the characters might not translate correctly, but they might translate correctly enough. So I've had this wonderful thing that, there are commands that have minuses next to them, which are the switches for commands, and the minus got converted into a longer minus that's different in a terminal, and it doesn't actually work exactly as it should, which is weird and amusing at the same time. Okay, so make sure everything you do is inside the Prometheus virtual machine. So the first thing that you need to do is you need to install OpenNebula. Now there are a couple of different methods that you can use in order to do this. I prefer to use the safest method, which is tell your operating system where on the internet OpenNebula is actually located, and then let your operating system go and download it itself. Okay, so in order to do this, we have files that we call repositories in the operating system. So they are located in etc. yamrepos.d. Okay, and we'll create a new repository and we'll call it opennebula.repo. All you need to do is type the gedit command in the terminal, and that will basically open the file editor. And then you can basically copy and paste the contents of this box into that file. Once you do that, you will create a file that tells the system that you can download OpenNebula from downloads, OpenNebula.io, repo 6.2, blah, blah, blah. Once you do that, you need to tell the system to read this new repository that you've created. So you yum make cache and yum install EPEL release. Those commands will tell your operating system that there's a new source available for OpenNebula. Once you do that, the easiest method to install software in Linux, particularly in Red Hat based Linux, is yum install whatever you want it to be. So in our case, we want to do yum install OpenNebula server and OpenNebula Sandstorm. All right, and then we'll do yum install OpenNebula Gate and OpenNebula Flow. With those items out of the way, we can then set up a few details. So the first thing that we need to do is we need to give a password to our one admin user. The one admin is the administrator of the OpenNebula software that we'll be using. Okay, it's called one OpenNebula. Very clever. So one admin needs to have a password. You basically SU one admin, so you switch user to one admin, and you do echo one admin localhost one and that file. So once you do that, then that file will contain basically the characters one admin localhost one, and that's all it needs to have inside it. All right. If you exit that, it's very important that you get this right, because if you don't change the password correctly at this point and then you restart the services and everything else, then that will stop being, you'll stop being able to change the password anymore. Okay, so you need to do it some other complicated way that I really don't want to do. Yes, so make sure you get this right at this point before you start all of the OpenNebula services. We'll also need to go into the Sandstone server config file. So this is the configuration file for the Sandstone service, and you'll need to tell it to stop trying to use FireEdge. FireEdge is another web interface. That's just a more fancy way of doing the same thing that Sandstone does. Okay, and we don't want to use it. I don't want to install it. So all you need to do is put hashtags in front of the last two lines in that configuration file, and that's it. That's done. Once you make those changes to this file, you can then start OpenNebula and OpenNebula Sandstone, the two services that the system needs to use. And in order to verify the installation, you can open a terminal and you can type one user show. So that will contact your OpenNebula server. It will find the users that are available to use there, and it will tell you, oh yes, I have a user, he is ID 0 because he's the first user, his username is one admin, and his password is something stupendously complicated, which is the host function of localhost one. All right, that means that your services are running, you have your user that's working, and what you installed just now actually works. You can also verify that it all works by clicking on HTTP localhost 9869, and that should open the web interface of Sandstone, and you should be able to log in there as user one admin with the password of localhost one, as you've just set it up before, and you should be able to see the system as it runs. The next page contains some locations for the directories structure, so where everything basically is, important information that you need to know, and you can always go back and refer to this if in the future you need to find, for example, a log file or something like that. So there's nothing to actually do in this page. And the next step is to do the KVM node installation. Remember, you need to be able to start up virtual machines on your server because it will be your virtualization server. So you basically need to install the software that's called KVM node. All you need to do is yum install OpenNebula node KVM and then restart the virtualization services on the computer, and it will be done. Once you do that, you need to configure passwordless SSH. So you need to have a way for your virtual machines and the 1D and scheduler services to be able to communicate with each other so that the scheduler can basically go and check that, if a virtual machine is running or if it's crashed and so on. So you need to have passwordless SSH in place so that they can do that. And for this to happen, you need to switch to one admin, and then you need to edit the file that's called config in your .ssh folder. It's a .ssh folder because it's a hidden system folder, okay? And because you're logged in as one admin on a terminal, because you did SEU, because you cannot log in physically as a user on the computer, one admin, because it's only an OpenNebula account, you need to edit this file in the terminal. So you cannot use gedit in this case, you can use vi. So this line here says, once the file is open, press insert on your keyboard, the insert button, don't type insert, yeah. Go to edit, so that you go into edit mode, and then find line, I think it's about line 37, host star and strict host key checking. Your file by default will say strict host key checking yes, and that line underneath it, the user known host file dev null, will not exist. So you need to add that line into that configuration file. Once you do that, you can save the file and exit back to the terminal by pressing the escape button. That will take you out of the editing mode, and then you need the colon WQ for write quit. And then once you press enter, you'll be back into the terminal where you were as logged in as user 1 admin. You then change the permissions of this config file with chmod 600, and then you're ready to try this, and you should try SSH localhost, and you should just log in. So the user 1 admin, as you are already logged in, should be able to SSH in the current computer, in the local host, and it should log in and not ask you for a password. If it asks you for a password, you shouldn't type localhost 1. You should go back and edit the file correctly, or you should call us because something has gone wrong. Okay, you should just log in, not ask you for a password, then it's done. And finally, you can go back to the web interface and you can log in as user 1 admin with the localhost 1 password, and then you should be able to use your cloud from there on. So the lab sheet after this is basically you working inside the Sandstone interface in order to build your first virtual machine and so on. Okay, I know there are lots of different moving parts to this. It will make more sense when you're in the lab and you can see everything in front of you. Okay, but the idea is that we download the software, install it, configure the password for the 1 admin user, configure SSH, passwordless SSH for the services that needed, and start up the web interface and log into it so that we can actually see our cloud. Okay. All right. Any questions about all this? Okay, so I will stop the recording.